Hi, this is Tom, and in this video we're going to factor by grouping, and here's why. The problem reads factor ax plus ay plus bx plus by, and right off the bat we can't factor anything, and here's the reason why. Notice that the first two terms have a's, but there's no a's in the next one. There's some x's spread throughout, and same with the y's. But the problem is that no GCF in all. That's the key part. It has to be a greatest common factor. It has to be in all terms. But look at this. But there are common factors. If the problem is made into groups. If the problem is made into groups. Alright, so let's take a look at what those problems are. So I'm going to rewrite the problem. For good formatting, we write the problem that we're working on. Ax plus ay plus bx plus by. So I'm going to write it like this. I'm going to write it as ax plus ay plus bx plus by. But notice this. This is group 1. This group has, I'm going to write it this way. It's not a greatest common factor. So I'm going to be a little creative here and put a line through the G, because it's not a greatest common factor, because that would mean that it's in all terms. It's just a common factor. But it has a common factor of A. And this next piece here, this group has a common factor of B. Now, also, I'm going to use another color to kind of accentuate this. Notice this. Use not parentheses. And the reason for that is parentheses in certain circumstances can actually change the problem. Just use some little underline. Like I like the curly brace. Some people I've seen use just a straight line. Either is okay, but whatever you do, don't start putting parentheses into the problem, because if you're not careful, you can change the problem. So now let's proceed and let's use the distributive property on each group. So if I use the distributive property on the first group, I have A parenthesis x plus y plus the distributive property on the second group says B times x plus y. But wait, look, this is like the problem in the previous video where we had a plus h in the parentheses. In other words, now the greatest common factor, and it is a greatest common factor, is x plus y. So I can rewrite the problem as x plus y, and then I write exactly what remains, which is a plus b. Let's try one more problem with some numbers, and we'll illustrate some pretty interesting ideas. So again, let's try this. Factor 3xy minus 4y minus 4 plus 3x. Okay, so there's a few different approaches, and I'll try both. 3xy. I'm going to just rewrite the problem. That's just good practice in math. Minus 4 plus 3x. So there's no GCF in this entire problem. Okay, so let's come over here and let's just make two groups. My first group, I'm not going to do anything fancy. 3xy minus 4y. My second group would be minus 4 plus 3x. And just to help us keep track of our groups, I'll just put the curly brackets under each group. Okay, now let's see. Our common factor in our first group, it looks like we just have a y. And in the second group, I'm not seeing any. So I'm going to just put a little question mark, and we'll see what happens here in a moment. So my first group becomes y. I have a 3x minus 4. Now, look at this. Minus 4 plus 3x. If this is just addition, I could switch the order of those. So I could say that's y. 3x minus 4. I could also write this as plus 3x minus 4. Wow, look at this. This piece here, 3x minus 4, looks like the common factor over here. Well, it's because they're the same. But here's the catch. In order to create a greatest common factor, we need to factor something from 3x minus 4. And the something is 1. You can always factor a 1. In this case, it makes all the difference in the world. Plus, if I factor a 1, this becomes 3x minus 4. Now, my greatest common factor is the entire piece, parenthesis, 3x minus 4, parenthesis. So if I factor that out, I now have 3x minus 4 times, I write what remains if the 3x minus 4 is removed, and it looks like I have a y plus 1. And that is how you factor by grouping. This is Tom. Thank you for watching.